Hello everyone. In this video, we are going to discuss about metals, nonmetals and metalloids from the chapter 3 classification of elements and periodicity in properties class 11 chemistry. You see, in our previous video, we have discussed about S block elements, P block elements, D block elements and F block elements. You see that is elements can be classified into S block, P block, D block and F block. Similarly, the elements can also be classified into metals, nonmetals and metalloids. So first let us discuss about metals. See, more than 78% of non-elements are metals. See, metals have very high melting point and boiling point. Usually they have high melting point and boiling point. High melting point means they require more energy to change from solid to liquid state. And high boiling point means they require more energy to change from solid to gas state. And you see, metals are good conductors of heat and electricity. Metals are malleable. Malleable means they can be flattened into thin sheets by hammering. For example, gold, silver, etc. can be shaped into coins, jewelry, etc. Iron can be shaped into tools, machinery parts, etc. And you see, metals are ductile. That means they can be drawn into wires without breaking. For example, copper can be drawn into thin wires for electrical applications. Aluminium can be drawn into wires for various uses. See, metals are usually solid at room temperature. They are usually solid at room temperature. Most of the metals are solid at room temperature, but there are a few exceptions. For example, mercury. See, it is actually a liquid at room temperature. Its melting point is minus 38.8 degrees Celsius. When you consider gallium, its melting point is around 30 degrees Celsius, or which is almost equal to 303 Kelvin. That is just below the room temperature. Similarly, when you consider cesium, its melting point is 29 degrees Celsius, which is just below the room temperature, which is approximately equal to 302 Kelvin. So you see, metals are usually solid at room temperature, but there are a few exceptions like this. So when we look at the periodic table, you see the S block elements are metals, D block elements are almost metals, and here we have aluminium, gallium, indium. These blue colored ones are metals. Also here we have lanthanoids and actinoids. These are also metals. Okay. Now when we consider the case of non-metals, see, the non-metals are located at the top right hand side of the periodic table. Non-metals are located at the top right hand side of the periodic table. That is, these are non-metals, these green colored ones, as well as these noble gases, 18th group, these are also non-metals. So you see, in fact, in a horizontal row, the property of elements change from metallic on the left to non-metallic on the right. That is, non-metallic character actually increases from left to right. Metallic character decreases. That is, when we move from left of the periodic table to the right of the periodic table, see, here on the left hand side we have elements with metallic character. Okay, and here we have, these are elements with metallic character. These are elements with metallic character. And here we have these orange colored ones. Here we have metalloids or semiconductors that exhibit properties intermediate between metals and non-metals. And at the rightmost end, we have non-metals. These green colored ones and these 18th group elements are non-metals. See, non-metals are usually solids or gases at room temperature. For example, if you consider carbon, its allotropes, diamond or graphite, it is a solid non-metal. When you consider sulfur, it is a yellow solid. Hydrogen, colorless gas. Fluorine, pale yellow gas. So non-metals are usually solids or gases at room temperature. And non-metals, they have low melting and boiling points. Usually they have low melting and boiling points. Here you can see the melting and boiling points of hydrogen, and similarly the melting and boiling point of chlorine. You see it's a very low value. Okay, so usually nonmetals have low melting and boiling points. But there are a few exceptions in this case as well. Because when you consider boron and carbon, they are nonmetals, but they have exceptionally high melting and boiling points due to their unique atomic structures and strong covalent bonds. That is, you see the melting and boiling points of boron is given here, and melting and boiling points of carbon is given here. You'd see these are actually very high values. So boron and carbon have very high melting and boiling points, but usually all other non-metals have very low melting and boiling points. Nonmetals are poor conductors of heat and electricity. See, most of the non-metallic solids are brittle. That is, they are neither malleable nor ductile. Most of the non-metallic solids are brittle. Brittle means they are prone to breaking when subjected to stress or impact. And you see, the metallic character of elements increases as we go down the group. The metallic character of elements increases as we go down the group of the periodic table. The non-metallic character increases as one goes from left of the periodic table to the right of the periodic table. That is, from left to right across the periodic table, the non-metallic character increases, but in a group from the top to bottom, the metallic character increases. From left to right, non-metallic character increases. From top to bottom in a group, that is, as we go down the group, the metallic character increases. And you see, when we come to the point of metalloids or semi-metals, these are actually the group of elements in the periodic table that exhibit properties intermediate between metals and non-metals. So you see, metalloids are located along the border between metals and non-metals. See, these orange colored ones are the metalloids, and this side we have metals and this side we have non-metals. So metalloids are actually located along the border between metals and non-metals. The metalloids in the periodic table are, you see, silicon, germanium, arsenic, antimony, tellurium, polonium, astatine. So these are the metalloids in the periodic table. So in this video, we have discussed about the metals, metalloids and non-metals. I hope it is clear to you. Thank you.